Hello my dear students and welcome once again to Zenith Academy Online. So students, I have already taught you the whole chapter of sulfuric acid, correct? So today I am going to explain you the manufacture of sulfuric acid, or maybe you can call industrial manufacture of sulfuric acid by a very important process known as contact process. So I will explain you contact process in detail. So be with me till the end of the lecture. I will explain you each and every chamber properly, the reactions of the chamber and the conditions along with the reasons, along with Le Chatelier principle. So please understand very carefully. So this is the whole setup. You can see we will start from the beginning. One by one I will explain. The first part of this industrial setup is a blower. Now from the blower, air is pushed in the pyrite burner. So let's start what is happening. One by one we will take. So air is blown from the blower in the pyrite burner. So first we are talking, so A was the blower, A part, and B part is pyrite burner. So let's see what happens in pyrite burners. So it is a type of furnace, you can say pyrite furnace or pyrite burner, in which iron pyrites, so we have kept here iron pyrite, FeS2 is known as iron pyrite, okay, or sulfur. Now iron pyrite or sulfur is burnt in presence of oxygen, okay, here the oxidation happens. So when the oxidation of iron sulfide will take place, you will form iron oxide Fe2O3, okay. So this is Fe plus 3 wala valency, right? Fe3 plus. Okay, so Fe2O3 and sulfur dioxide gas will be formed. When sulfur and oxygen reacts, it will form sulfur dioxide. So what is happening? Iron pyrite or sulfur burns in presence of oxygen to form, basically we want to form SO2. Okay, and here Fe2O3 is also formed, and then you balance the reaction. The balancing of reaction is really important. So I will not waste my time in balancing. I have already explained you balancing in detail. So you just understand in iron pyrite, in pyrite burner what happens? The iron pyrite and the sulfur burns in presence of oxygen to form SO2. This is the first step. Okay. Now, if you see, this hole is a purification unit. From here to the test box, this hole is a purification unit. From here to here. Okay. So in the purification unit, the first chamber or the first tower, this one is known as dusting tower or dusting chamber. Now what happens in the dusting chamber or dusting tower? The gaseous mixture obtained from pyrite burner is passed through a chamber where the dust particles present in these gases are removed by downward blow of steam. Now these chambers are called dust chambers or dusting tower. So what happens? So from the pyrite burner here, the mixture has gone here. What was the mixture? SO2 and Fe2O3, right? And here from the top, what comes? Can you see? From the top, okay, a blow of steam comes. Okay, the steam blows in so that all the dust particles which were present in those gases are removed by downward blow of steam. Okay, so this is known as a dusting tower. Now comes the washing tower. Can you see this? This one is the washing tower. It is also known as scrubbing tower or scrubbing chamber. Okay, so now the gaseous mixture obtained from the dust chamber is sent to the washing tower. Now what happens in the washing tower? Can you see here? Water. Can you see here? There is water. So in this tower, water is rained from the top side and the gases received from the dust chamber are flowed from the bottom. Okay. Can you see here? From the bottom, the gases are coming here and water is coming down. So the water is basically sprayed on it. So the remaining dust particles and some other impurities are absorbed by the water. So initially in the dust chamber, there was steam flowing down. In the next one, now there is a jet of water flowing down. So all the other dust impurities and other impurities are absorbed by water. Okay. Once it is absorbed by water, the gas, the cleaned gas is passed from here. Can you see? Wait, I will again show you with the highlighter. Okay. So now the gas, here was the gas. So the gas comes from here and now it enters this tower. Okay. Now what is the next tower? Drying tower. So let's see what happens in the drying tower. See this drying tower or drying chamber. You can call it anything. Just let me change the pen. Okay. So now the gases received from the washing tower are passed down to another tower. In this tower, drops of concentrated sulfuric acid keeps dripping from the top. Now here can you see there is concentrated sulfuric acid. So these drops keep on dripping from the top. The concentrated sulfuric acid, okay, pay attention here. The concentrated sulfuric acid absorbs the water vapor present in the gas, because in the previous step in the washing tower we had sprayed water, so that it will be moist, the gas will be moist. So now this concentrated sulfuric acid, what does it do? It absorbs the water vapor present in the gases. The gas was moist, so it absorbs all the water vapor obtained from the washing tower, and the gases obtained from the drying tower are dried. So you all know that concentrated H2SO4 is a drying agent. It is a dehydrating agent. It captures water, right? So now the gas that we obtained is absolutely dry. Okay, that is water vapor is not present in them, right? Now you see the dried air, okay, here. From here the dried air enters from the top, it goes down here in the arsenic purifier. So the gaseous mixture obtained from the drying tower is sent to the arsenic purifier. Now what is arsenic purifier? It is filled with ferric hydroxide. Can you see here on these shelves? Can you see there are shelves made here? So on the shelves out here, there is ferric hydroxide. Okay. Now it absorbs the impurities of arsenic present in the gaseous mixture obtained from the drying tower, and the gases are purified. Now whatever gases from here we have taken those dried gases. So here ferric hydroxide is placed. So ferric hydroxide, what does it takes? It reacts with the arsenic which is present as an impurity in the gaseous mixture, right? That is why it is known as arsenic purifier. Okay. So the reaction of this reaction is not important. This reaction will not come, that how how your ferric hydroxide reacts and removes arsenic. Okay. Now comes the test box. Okay. Here is the test box. So in this box, the purity of the gaseous mixture obtained from the arsenic purifier is checked. Purity is checked. Now how is the purity checked? Let's check. Let's see. The pure gaseous mixture consists of SO2 gas and the remaining gases of air. So in these boxes, rays of light are passed through the gaseous mixture obtained from the arsenic purifier. So in this box, there is ray of light is passed. Now what happens? If the gaseous mixture is impure, then the particles of the impurities are seen glowing in the test box. Okay, you can see the impurities glowing. A pure gaseous mixture is transparent and no glowing particles are seen in it when the light passes through it. So this full chamber, from this full part from here to here, this was known as purification unit, right? Because in the dust chamber, the impurities were cleaned, was purified with the blowing steam. In the washing tower, the further impurities were washed away with water. In the drying tower, the water vapor was absorbed, was dried because of concentrated H2SO4. In the next arsenic purifier, what happened? The impurity arsenic was removed, right? And in the test box, now it is tested for purity, correct? Now the most important is contact chamber. So let's talk about contact chamber or contact tower, or it is also known as converter unit. Okay. So let's talk about this thing now. I am circling it. We are talking about this. So the pure gaseous mixture obtained from the test box is sent through ion channels to ion chamber. Now this ion chamber is called contact chamber or converter. and its temperature is about 450 degrees Celsius. In the end, I will tell you why this temperature, why a particular pressure and all, right? So you have to remember that this contact chamber is made up of iron. It is maintained at a temperature of around 450 degrees Celsius. Now, iron tubes are filled with platinum containing asbestos or vanadium pentoxide. Okay, so it has a catalyst vanadium. It has a catalyst platinum or vanadium pentaoxide. So these are the two catalysts which can be used, platinum or vanadium pentaoxide. But platinum is expensive, so we mostly use vanadium pentaoxide, right? Now in this cell, what happens? SO2 is oxidized to SO3. The major part of the gaseous mixture obtained from the contact chamber is SO3. So what is happening here? The SO2 gas, the purified SO2 gas is oxidized to SO3. Are you able to see the reactions? So just balance it now. So 1, 2, 3, 4 oxygen, and here there are only 3 oxygen. So you make it as 6, and here also now it is 6. Correct? So what is happening in contact chamber? Sulfur dioxide is getting converted to or getting oxidized to sulfur trioxide in the presence of catalyst vanadium pentaoxide or platinum. Okay. Now here one very important thing about the catalyst I want to tell you. Why vanadium pentaoxide? Why V2O5 is preferred? Okay. Now vanadium pentoxide is preferred as a catalyst during catalytic oxidation of SO2 to platinized asbestos. We don't use much of platinized asbestos. What are platinized asbestos? Platinum containing asbestos. तो वो हम यूज नहीं करते हैं ज्यादातर और हम प्रेफर करते हैं V2O5. Why? Because it is comparatively cheaper, सस्ता है, and less easily poisoned. ठीक है, जल्दी से पॉइजन नहीं हो जाता. इट इज लेस इजिली पॉइजन और susceptible to impurities. Impurities do not react much with V2O5. Okay, it doesn't become impure, right? So it is cheaper, less easily poisoned or susceptible to impurities. Is that clear? Now, one more thing that you should understand here, that vanadium pentoxide is a catalyst. So we can sometimes use a promoter as well. What are promoters? See, promoter. What are promoters? Promoters are something that enhance the activity of the catalyst. So we use potassium oxide. Potassium oxide. Now K2O. Okay, potassium oxide is used as a promoter. Okay, promoter are ones which enhance the activity of the catalyst. Okay, so if they ask you, you should know K2O or potassium oxide is the promoter to the catalyst V2O5, and V2O5 is preferred over platinum containing asbestos. Okay, is that clear? Now one more thing, catalyst is only initially heated. Later on it does not require a heating because the process is an exothermic reaction. I will tell you about the reactions in detail. Dekho, here also I will tell you in short that whenever your SO2 reacts with O2, it forms SO3. Now this is a reversible reaction. Can you see I have made these type of an arrows? This is a reversible reaction. V2O5 is acting as a catalyst and a lot of heat is released. Okay, so it is an exothermic reaction. So once they start reacting, the heat is enough to maintain the reaction. So initially you just have to heat the catalyst in the beginning. Later on it does not require any heating. I hope the whole process of contact tower is clear. Now let's go ahead with the absorption tower. Okay, this tower is packed with quartz or acid proof stone. Okay, it is packed with quartz or acid proof stone in which 98% H2SO4 is sprayed from the top of the tower. Can you see? Concentrated H2SO4, which is 98% concentrated. 98% H2SO4 is sprayed from the top of the tower. Now, this concentrated H2SO4, what does it do? this concentrated H2SO4 absorbs sulfur trioxide to form oleum or pyrosulfuric acid. You see here this H2SO4, concentrated H2SO4 reacts with this SO3 gas, okay, which we got from the contact chamber, and it formed oleum, H2S2O7. This is known as oleum or pyrosulfuric acid. Both the names you have to learn very carefully, oleum or pyrosulfuric acid. Now this oleum is treated with calculated amount of water. How much ever we want to see, we have got this oleum. So this oleum goes into a tank. Okay, this is known as a dilution tank. What is it known as? Dilution tank. So in this dilution tank, we add water. So when water is added, okay, H2S2O7 oleum reacts with water to form sulfuric acid. This reaction is the final reaction. Oleum reacts with the calculated amount of water. How much dilute we want the H2SO4? We add that much amount of water. So H2S2O7, that is the oleum or pyrosulfuric acid, reacts with water to form sulfuric acid. Okay, so if you see here again, I will just move a bit and show you this thing. Can you see now properly? Okay, so I will just quickly revise. See here what happens in the wait. So from the blower, you can see the air coming in. Now here in the pyrite burner, what happens? Iron pyrite or sulfur burns and form SO2. Now this full from here to here, from here to the test box, this is purification unit. So here earlier in the dust chamber, steam is blown. So with the help of steam, everything is cleaned. Okay, SO2 is cleaned. Then in the washing tower, water is sprayed from the top. So again the impurities are cleaned. In the third step, in the drying tower, okay, what happens? Concentrated H2SO4 is sprayed. Now concentrated H2SO4 is a drying agent, so it will absorb or it will dry the SO2 gas, okay, and all the moisture will be removed. In the arsenic purifier, okay, arsenic impurity is removed. In the test box, it is tested. Now next is the contact chamber. So purification unit is over. Now the catalytic oxidation takes place. So in the contact chamber, what takes place? Catalytic oxidation. Why we call catalytic oxidation? Because see, I am writing here the reaction. SO2 is getting converted. Wait, I'll have to move again here a bit because I will not be able to write. Just a second. I will first write this and then I will move. So what happens in this chamber? In the contact chamber, your SO2 is getting oxidized to SO3. It is an irreversible reaction. I'm so sorry for the handwriting. It takes place with the help of a catalyst. That is why it is known as a catalytic oxidation, and it releases a lot of energy. I think 45 kilocalories of energy is given out. So it is an exothermic reaction. So here catalytic oxidation takes place. Now I am moving again. Right. Next is the absorption tower. In this, absorption of SO3 takes place. So there is concentrated H2SO4 sprayed from the top. SO3 reacts with H2SO4 to form oleum. And next in the dilution tank, what is happening? So here we have got oleum. Now in the dilution tank, the oleum reacts with water to form H2SO4. Okay. So now let's go to the, now let's see here the flow chart of this. So what is happening? Air and sulfur or iron pyrite comes here in the combustion furnace. Okay, and you form here SO2 and heat is recovered because this is also an exothermic reaction, right? So now this SO2 which has been formed, okay, is first purified and then it reacts with air in the presence of catalyst at 450 degrees Celsius and forms sulfur trioxide. Here also heat is recovered because again here this is also again an exothermic reaction. Okay, now this sulfur trioxide reacts with concentrated sulfuric acid to form oleum. In oleum we add required amount of water to form sulfuric acid. Okay, so you have to remember that the catalyst used is vanadium pentoxide or platinum, but vanadium pentoxide is preferred over platinum. I told you why. Then temperature has to be maintained between 450 to 500 degrees Celsius. You have to remember the temperature, you have to remember the pressure, catalyst, everything. I will tell you the reason why it is 450, okay? Now pressure has to be 1 to 2 atmosphere. You have to remember this as well. And the conversion ratio, okay? So 98% of the sulfur dioxide which we have formed in the initial process, 98% of this sulfur dioxide is converted into sulfur trioxide. This is the conversion ratio. Now let's talk about the conditions of the optimum yield of H2SO4. Now this is really important, children. Okay. Now formation of SO2 to SO3 is one of the most important steps in the manufacture of sulfuric acid. Now, the production of H2SO4 entirely depends on the amount of SO3 formed. Okay, so this reaction is the most important, conversion of SO2 to SO3. So you remember the reaction: 2 molecules of SO2 reacts with 1 molecule of oxygen to form 2 molecules of SO3, and around 45 kilocalorie, so around 45,200 calories heat is evolved. So it is an exothermic reaction. So can you see this? This means it is a reversible. This energy on the right hand side means it is exothermic. And this proceeds with a decrease in volume. What do you mean? देखो यहाँ पे there are 2 molecules of SO2 and 1 molecule of oxygen. It is forming 2 molecules of SO3. So from 3 to 2 there is a decrease in volume. So you understand that this reaction is reversible, exothermic, and proceeds with decrease in volume. Therefore, okay, we can apply Le-Chatelier's principle, okay, for the maximum yield of sulfur trioxide. So see here, first thing, if you see, this is an exothermic reaction. Wait, let me rub this all. Okay, so since it is an exothermic reaction, my dear children, the low temperature will favor the forward reaction. You all know what is Le-Chatelier's principle, right? So the equilibrium has to be shifted in a direction. Okay, this has to be, the reaction has to be shifted in a direction so as to maintain the equilibrium again. So if it is producing heat, it has to, the reaction has to be a low temperature. If forward reaction is to be if this forward reaction is to be favored, and if this is an exothermic reaction, then it has to be a low temperature. If we maintain low temperature, then exothermic reaction will be favored. Okay, now see the reaction, remember the reaction again. Now see the next, high concentration of reactant. Here you see there are 2, here there 1 and here 2. So total 3 is forming 2. So again, according to Le-Chatelier principle, okay, see, from 3 it is forming 2, right? So the reaction of the concentration of the reactants has to be high in order to make the reaction in the forward direction. So high concentration of SO2 and O2 is used for more production of SO3. Okay. So here Le-Chatelier principle, how it is applied, देखो यहाँ कम हो रहा है, right? This is getting decreased. So it has to, this reaction, this has to increase in order to favor the forward reaction. Okay. Now pressure. Now again, if you see, there are 3 molecules on the reactant sides. Okay, 3. And here there are 2. So there are less number of molecules on the product side, so less pressure. So to increase the forward reaction, it has to be, the product has to be here, the reactant has to be, this has to be with high pressure, right? ली चैटरली प्रिंसिपल क्या बोलता है कि equilibrium, to maintain the equilibrium, it has to shift to the opposite side. So if in the product there are only 2 molecules, the pressure is less. So in the reactant, the pressure has to be more in order to favor a forward reaction. So high pressure favors the reaction because the product form has less volume than the reactant. But, okay, now see, but we require high pressure. But the acid resistant tower which are able to withstand high pressure are difficult to build. So it is difficult to build the towers which are acid resistant and which can withstand high pressure. Okay, hence an optimum pressure of about 1 to 2 atmosphere is applied, right? Let's see the next condition. The next condition is use of catalyst. So rate of reaction is increased by the use of positive catalyst. So we have used vanadium pentoxide as a catalyst for higher yield of sulfuric acid. So I hope the conditions you will remember. I'll just go back to the conditions. Okay, you have to understand that this reaction is reversible. सबसे पहले you have to remember that formation of SO2 to SO3 is the most important step in the manufacture of sulfuric acid. And the production of the whole H2SO4 entirely depends on the amount of SO3 formed. So, since this is an exothermic reaction, low temperature is favored. But you should also understand low temperature is required for the maximum yield. But if we take very low temperature, too low temperature, then it takes a longer time to attain equilibrium. So, too low temperature is too slow to attain the equilibrium. So, the optimum temperature is 450. Okay, 450 to 500 is the optimum temperature, right? Now, since the reaction is having only 2 molecules in the product side, okay, less molecules in the product side. So, according to Lee-Chatterley principle, the concentration of reactants have to be high. Next, you see 2 molecules, the volume is less on the product side. So the pressure has to be high on the reactant side. So high pressure favors the reaction because the product form has less volume than the reactant, but this is required, that high pressure is required. But it is very difficult to build acid resistant towers which can also withstand high pressure. Okay, so we take an optimum pressure of about 1 to 2 atmosphere. Okay, catalyst, you know, vanadium pentoxide, the promoter is K2O. And platinum can also be used as a catalyst, but since it is expensive and more susceptible to impurities, okay, and it is also more susceptible to poisoning, that is why we use vanadium pentoxide. I hope all this is really clear and you are able to understand the contact process very well. If you have not understood a particular step, you can go back and watch the video again and write in the comment box if you have any doubts. Okay. So keep the learning always on Zenith Academy online. And if you have any doubts, please do write to us. And if you have yet not subscribed, do it right away and tap on the bell icon to receive all the notifications. Thank you, my dear children, and have an amazing day. And keep the learning always on.